Hello students, hope you're all doing well. Welcome to another video by Quick Study. Today we will start another topic of physics, which is force. So, what is force? Force is a concept which refers to any push or pull on an object. Force can make stationary objects move, stop a moving object, accelerate its speed, or change its direction, shape, and size. It is a vector quantity, which means it has both magnitude and direction. As we learned before, the SI unit of force is Newton. So let's see how forces really work. In this figure, a man is pushing a car. The car is moving forward, but there is a force acting in the opposite direction, which is known as friction. We will know about that a little bit later. But when two people are pushing the same car, the car is moving faster. If the man gets someone to help him push the car, the forward force is bigger. Both the forces pushing the car are acting in the same direction. So you find the total forward force by adding the two forces together. If both people are pushing the car with a force of, let's take 300 Newton, then the total force would be 600 Newton. And the opposite force, which is the friction, let's take that as 302. So 300 plus 300 is 600. And the friction is in the opposite direction. So we have to subtract it. So the resultant force here is 600 minus 300, which is 300 newtons. Friction is a force that occurs when two surfaces slide or try to slide past each other. Let's imagine trying to push a book across the floor. Friction makes it difficult as it opposes the book's motion. In friction, we have to keep something in mind. Friction always will act in the opposite direction to the object's movement. We see examples of friction in our daily life. For example, walking. When we walk, the friction between our shoes and the ground prevents us from slipping. When we light a matchstick, the friction generates the heat, which ignites the matchsticks. Or let's say when we are driving a car, the friction slows down a moving car when the brakes are applied. As we are studying force, we have to know about a law called Hooke's law. Hooke's law was discovered by English scientist Robert Hooke in 1660. It describes the relationship between force and deformation in elastic materials. When an object experiences a small deformation, this deformation is directly proportional to the applied load or force. In simple terms, if we stretch or compress a spring gently, the force required is proportional to the amount of stretch or compression. This law has a limitation, which is called the elastic limit. This law will hold as long as the materials remain within this limit. For example, when a guitar is played, the strings of the guitar follow the tension and then return to their original shape after they stretch. This law holds true as long as the material remains within its elastic limit, the point beyond which the permanent deformation occurs. At that point, the object will not obey Hooke's law. For example, when guitars are played, the strings stretch and then come back to their original shape after stretching. To calculate force, there is a formula, which is F is equal to m into A. Here, F stands for the resultant force, m is mass, A is for acceleration. Force is measured in newtons, mass is measured in kilograms, and A, acceleration, is measured in meter per second square. From this, we can see that 1 newton is the force needed to make a mass of 1 kilogram accelerate at 1 meter per second. As we know from the triangle method, we can rearrange this equation however we want to. The equation can be rearranged if we want to find out the acceleration, which would be A is equal to F divided by m. Let's look at an example where we will use this equation of force. A car which is traveling at 20 meters per second collides with a stationary lorry and stops completely in just 0.02 seconds. Let's calculate the deceleration of the car. Deceleration or acceleration are similar things as we have learned before. Acceleration is equal to change in velocity divided by time taken, which is A is equal to v minus u divided by t. Here, as the car was traveling at 20 meter per second, the initial velocity will be 20 meter per second. And after hitting the lorry, the car completely stops. So the final velocity will be 0 meter per second. So the formula would be 0 minus 20 meter per second divided by 0.02 seconds, which is the time it takes to stop. So 0 minus 20 would be minus 20. Therefore, minus 20 divided by 0.02 seconds. The answer would be minus 1000 meter per second square. The unit here is minus because we were calculating deceleration. Now, we have to calculate the force. A person of mass 50 kg inside the car experiences the same deceleration when she comes in contact with a hard surface in the car. This could be the dashboard or the windscreen. Let's calculate the force. We know the equation of force is m multiplied by a. We just calculated a, and the mass of the person is given in the question, which is 50 kg. So F is equal to 50 multiplied by minus 1000. But we will take it as 1000 because force cannot be negative. So multiplying 50 into 1000 would come up as 50,000 newtons. Many times we mistake weight and mass. When someone asks us, how much do I weigh? I would say I weigh 60 kgs. So mass and weight are actually two different things. Mass is the amount of substance that anything has, but weight is a completely different thing. Weight is the force experienced by an object due to gravity. It acts towards the center of the earth or any massive body. The weight of an object is the force that acts on it because of gravity. So the weight of an object depends on its mass and the strength of the gravity. The gravitational field strength, which is G, is the force that acts on each kilogram of mass. There is a formula of weight as there is for force. The two are very similar, so let's look at this very carefully. We can work out the weight of any object by using this equation. Weight is equal to mass into gravitational field strength. In short terms, W is equal to m into g. Here we can again use the triangle method to work out any of the three. Near and on Earth's surface, the gravitational field strength is approximately 9.8 Newton per kg, but we use 10 Newton per kg to make calculations easier. The gravitational field strength on the moon is about 1.6 Newton per kg. So an object taken from Earth to the moon will have less weight even though it has the same mass. Let's look at an example where we will work out weight of an astronaut on Earth and also on Mars. Let's look at the example. An astronaut in a spacesuit with a complete life support pack has a mass of 140 kg. How much will the astronaut weigh on Earth and on Mars, where the gravitational field strength is about 1/3 of that on Earth? So, the force of gravity or weight of an object is given by W is equal to m into g. So, weight on Earth would be 140 into 10. It would come out as 1400 Newton. Then, gravity on Mars would be 10 divided by 3, as in the question it has said that 1/3 of on Earth, which would come out as 3.34 Newton per kg. So the weight on Mars of the astronaut would be 140 multiplied by 3.34. So it would come out as 468 newtons. Forces and its calculations are one of the most important parts of physics, as it will connect later on to other topics. That's all for today, students. Stay with us to learn more about physics and other subjects, as we post regularly on our channel. To know about our online tutoring service, please visit quickstudy.uk.